Another way of thinking about this is I know the point 3 comma 14,800 on the graph. I know that that point is 3 14,800. And I need to figure out what needs to happen if I go back in time. So in other words, if I undo 3 years to get back to 0, well, what would I have to do to get from 0 to 3? Since the price is only 82.1% of what it was each year, that means that to get from 0 to 1, I would have to multiply by 0.821. To get from 1 to 2, I'd have to multiply by 0.821. And to get from 2 to 3, I'd have to multiply by 0.821. So really, I would altogether be multiplying by 0.821 3 times. Now, if I'm working backwards, well, no, I don't multiply to work backwards. I multiply to move forward in time. So to get backwards in time, I'd have to take this amount and divide it by 0.821 to the third power, which is exactly what we really did. If you think about it, we just converted it to its full decimal and then divided by the approximation. So let's jump to the next part of the question, which is write a function that shows the purchase price of the car as a function of years since 2010. So here we know that our initial value is 2644. We want to know the value based on a function of time. And so far it kind of looks like this. That is how, actually goes down. That value decays, so it kind of looks like this. And we know that our value is started off as 2644, but it decays by, or it's multiplied by 0.821, and we do that for every year that passes by. So there is our formula for that particular problem. When can the car be purchased for half its original value? Okay, well that's a good question, right? Because we want to know, when is the value going to be half of what it started off as? And I think I wrote down the number incorrectly. 26,744 should be the number. And so we want to know, when will it be half? So when will the value be half of 26,744, or 0.5 times that if you want? And so we basically half of that would be, let's see, 13,372, I believe, equals 26,744.821 to the t. So we want to know, when is the y value equal to 13,372. So what I'm going to do is I'm going to graph both of these functions, my 26,744 times 0.821 raised to the x power. I'm going to set my window. Now I know x is time, so maybe I'm going to go from 0 to about 10 years into the future. And I know that the highest value the car will ever be is what I purchased it for, so I'll just set my window 27,000. And it's only going to drop from there, so it eventually we'll never get $0, but it'll begin to approach it. And there you kind of see the curvature, because we're decreasing by a percentage, not a constant amount. So that decrease becomes less and less and less as time passes by. Now I want to know, when is that value, when is the y equal to 13,372? And if I graph that, well, this is an intersection point problem. So I can actually go to second trace, calculate the intersection, number 5, enter, and I'm going to come over and make my guess right about there. And it guesses that t is about 3.5. So wow, that's pretty quick how fast that car decays in value, that within 3.5 years it has already achieved half of what it was purchased for. So that just gives us a perspective that about midway through 2013. Okay, let's take a look at a more challenging one. So then, this is a true statement. Populations are often modeled by exponential functions, since they tend to grow by a percentage rather than a constant number of people. So it really depends on how many people you have in the population, because of course they have kids, and that depends on how many kids are born, depends on how many people are alive. So in 2000, Nevada had a population of 2 million people, while Arizona had a population of 5.1. In 2010, Nevada had a population of 2.7, while